Hi, hello, assalamualaikum. This is our work-based project. The title of the project today is pipe in series. We choose this title because it be shown when the one and two pipe of different diameter are connected is series. Okay, so as we know, the total head loss in the pipeline is the sum of total energy losses. For example, HL is equal H at the inlet, H inlet, I call it H1. Okay, at the sudden enlargement H2 plus dengan H2, at the bends H3, and valve H4, and the axis losses at the axis, okay, plus H5. Okay, as we know, if we want to know the head loss, we want to total up the H1, H inlet, H sudden, H bend, H valve, and axis. Okay. So in the introduction, this pipeline system was built for purpose of accommodating the use of water in a company to facilitate the manufactures of good for daily use. Okay, firstly, if when it rain, okay, rain, okay, the tank will be open by worker to collect the water. Okay, after water is full, water in this tank was full, the valve will open to the valve. This valve will open to channel water from this tank to the storage tank. Okay, okay, okay. This valve are used to control the amount of flow and glove valve. This valve, okay, okay, okay. During this water transfer process, during this water from 1 to 2 process, a lot of energy will be lost among them. Okay. Firstly, at the storage tank to the inlet, it called entrance loss, H1. Okay, entrance loss ni is a special case of a contraction occur when a fluid from tank into a pipe. Okay, from this tank to the pipe. Okay, so this is a flow. Okay, from tank to the inlet. Okay, second, at the sudden enlargement, it will be shown as a water from a smaller pipe at this smaller pipe into a larger pipe. This is a larger pipe through a sudden enlargement. So from this to this through sudden enlargement, this one. Okay, its velocity decrease causing turbulence, which generate energy loss. Okay, finally, at the axis, the energy loss we call axis loss. It was occur from flow from pipe into a tank. See, this pipe into the tank. So at this part, the velocity is decreased to very nearly zero. Okay. This is an introduction for our best project. So if you want to know more, stay tuned to the next video.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Muhammad Amsuddin bin Muhammad Hazi, AB 19150. Jadi saya akan terangkan dari segi calculation ataupun penerangan. Jadi kita boleh tengok soalan dia. A tank of water empties by gravity to a horizontal pipe into another tank. There is a sudden enlargement in the pipe as shown. At a certain time, the difference in level is 12 meter. A friction coefficient CF equal to 0.005. The inlet loss constant is K, which is K is 0.3 and D equal to 2 and V equal to 3. Jadi jalan kerja dia adalah untuk dapatkan energy loss tu kita guna formula HL sama dengan K kurungan V kuasa 2 per 2G. HK ni adalah minor loss. Jadi K equal to, jadi kita guna formula K sama dengan 1 tolak A1 per A2 kurungan kuasa 2 sama dengan 1 tolak D1 per D2 tutup kurungan kuasa 2. Jadi untuk dapatkan resistance for value K sama dengan kurungan LE per D kurungan FR. Jadi RO adalah radius outside band tu dan R1 radius inside. Jadi untuk formula R tu, R sama dengan R1 tambah DO per 2 dan R sama dengan RO sama dengan negatif DO equal per 2 dan R sama dengan RO plus R1 per 2. Jadi untuk dapatkan total head dia, P kita guna formula P per PG plus V2 per 2G plus Z. Jadi kita akan dapat K tu dia sama dengan 1 tolak V A2 tutup kurungan kuasa 2 sama dengan 1 tolak D1 D2 tutup kurungan kuasa 2. Dan kita akan dapat K sama dengan 9. Lepas tu kita pun cari resistance of coefficient dia. Jadi kita guna formula HL sama dengan K kurungan V kuasa 2 per 2G. Dan kita kira yang ni dapat 9 3 kuasa 2 darab 9.81 dan kita akan dapat jawapan dia 4.41. Seterusnya kita cari sudden enlargement. Kita akan dapat HL sama dengan cos 1.0 darab 3 kuasa 2 per 2G dan dia akan dapat 0.46. Lepas tu kita cari exit loss. HL sama dengan 0.46 darab 3 kuasa 2 per 2 darab 9.81 dan kita akan dapat exit loss dia 0.21 dan gradual enlargement dia HL sama dengan K darab V kuasa 2 per 2G kita akan dapat 0.36 darab 9 darab 19.62 dan kita akan dapat jawapan dia 0.16.
Untuk pengiraan sudden construction, kita perlu cari K. Untuk cari K sama dengan LE per D darab FR. dan nilai K ialah 340. Untuk formula sudden construction, K darab V kuasa 2 per 2G. Untuk jawapannya ialah 739.13. Seterusnya, pengiraan untuk resistor coefficient value. Formula ni ialah radius outside B tambah dengan radius inside B per 2. Jawapannya ialah 1.75. Dan selepas itu kita totalkan semua head loss daripada resistance coefficient, sudden enlargement, axis loss, gradual enlargement, sudden construction dan resistance coefficient value. So total semuanya ialah 746.12.
Discussion. The head loss in the pipe system can be reduced by having some good design. Here are some ways to reduce head loss in pipeline system. Firstly, having a correct size of pipe. It because undersized pipe will lead to increased head losses due to increased friction. However, oversizing pipe beyond reasonable limit will increase the apex and commission costs. Hence, the pipe should be sized optimally for minimal head loss. Secondly, optimize the network length. Because as the length of the network increase, the head losses increase. Attentionally should be paid to the network design to ensure that water reaches all the end user with minimal length of the pipe. Thirdly, inner surface roughness of the pipe. It because the inner surface roughness of the pipe play key role in determining the friction losses. The roughness coefficient for the different diameter and material can be found in the guideline for designer water supplies and network. For example, the India Central Public Health and Environmental Engineering Organization CPHEEO Manual on Water Supplies and Treatment. Fourthly, statement line design. It because as the number of the pipe, valve fitting and other obstruction in the system increase, both major and minor losses pipe up. Therefore, a good hydraulic consultant should be engaged for a streamlined line pipe design. That's all.
Okay, for the conclusion is according with this analysis, the following remarks can be made. For the first one is generally all formulations allow the estimation of the maximum overpressure after a fast maneuver. However, the differences increase with the simulation time depending on the capability of the transient model to describe the most important parameters of the system. For the last one is being the plastic pipe with a future increasing application, the viscoelastic effect must be considered either for model calibration, leakage detection, or in the prediction of operational. And the condition, example, startup or trip of electromechanical equipment and valve closure or opening. Thank you so much.